Hi everyone, good evening. Today's session we are going to talk about workload management. Workload management is a quite additional concepts are involved in the workload management. Before we deep dive into the workload management concept, first we can focus on the containers. What is the importance of containers and what are all the challenges in containers and pods. And once we're familiar with the container and pods, it's easy to understand the Kubernetes concept. And these three concepts are the foundational concepts for Tanzu. Okay, and in simple terms, Tanzu is like a enterprise Kubernetes platform. So that is this is the main icon is refers to the Tanzu icon, and we are going to learn vSphere with the Tanzu. But vSphere with the Tanzu is like a enterprise container platform, a container platform, or we call it as a enterprise Kubernetes platform. And this icon refers as a Kubernetes icon. Okay. Before we dive into the concepts, first we'll focus on the basic concepts, and then we'll go to the Tanzu. So today's agenda, let's we quickly recap our evaluation of modern applications, and I will show you the quick overview of workload management. But before going to the dive into the workload management concept, we'll try to understand the containerization. What is the before containerization challenges, after containerization solutions, and container terminology and key components. Once we're familiar with container, then we'll go to the advanced concepts in our home lab. And the right side, highlighted the icons. We already know this is a vSphere icon, and Docker is the most popular container technology. So this is the icon for the Docker, and Kubernetes. This is icon for the Kubernetes, and this is the Tanzu icon. Okay. Now let's quickly recap our evaluation of modern applications. So within our modern applications, in our previous session, we already talked about these topics. Let's quickly understand. In our previous scenario, traditional environment, we have only physical servers, but in the virtualization scenario, we have a virtual machine. Now this is a next generation. Within our virtual machine level, instead of maintaining a single application within one virtual machine, we can maintain a multiple applications. But how we can maintain multiple applications is that is within the container format. And the physical view for containers is this is the physical view of container. And today we can talk about what is the definition for container and all. And the architecture perspective, the virtualization architecture, we can prepare your applications in a multi-tier application. But before multi-tier, in our traditional concepts, we configure all the applications in a monolithic applications. That means all the web app DB is running on a still on a single point of server. But when comes to the virtualization scenario, where the application layer is enhanced to the multi-tier, you can maintain two-tier applications, three-tier applications, and so on. Three-tier means, let's say web app DB, instead of maintaining on one tier, one server, we are maintaining a different layers of servers. For web, one server, application, one server, database, one server, and even if you have a load balancers, we can maintain a separate layer. So it's a multi-layer application. But when it comes to the latest concept, the entire the application, modern applications are developed like a microservices architecture. Microservices, the name itself, it's a microservices. That means all the applications are decoupled from the operating system dependency, and they divide, they break the bulk application. Let's say we have a one major application. That major application also, when we install one application, it's running with some services in our operating system level. All these services, they make divided it, break it into a multiple services. That means it become as a microservices. Instead of one large container, one large package, they make it into a multiple microservices. Okay, and the development process wise, we call it as previous process was waterfall model, and the advanced to waterfall is agile, and now the current generation of development process is running on DevOps. Dev means development, and Ops means operations. Okay. Now we'll quickly understand the modern applications difference between monolithic and microservices. Modern applications, the definition of an application has changed or improved. And an application used to be built as a monolithic. Monolithic means that is single or large code basis. So developer can run all the code on a one single system only. And when comes to the modern applications are built with microservices and APIs, application program interface. So it's completely based on the API calls. And we can deploy like a small modular code basis that are easy to update, to replace and innovate. If you see in this diagram, the developer, they break the one application to multiple services. So one service specifically for API gateway, and one few services specifically for web user interface, and remaining all the services we can access through REST API, RESTful API. So using APIs only we can contact. That means instead of maintaining a one large unit, we are just maintaining a smaller module of units. Okay, and building applications as microservices has encouraged the use of container. So how we can make this microservices? Its main concept is containers, and that's why most companies run containers on virtual machines instead of physical servers. Also, containers prefer to run on a virtual machines, and more than 80% of containers run on virtual machines at present in the current market. Okay, now let's talk about high level overview of our vSphere workload management. Okay, this is a vSphere workload management. This workload management, I just captured the screenshot from our vCenter server, our lab vCenter. When we log into the administrator from the home shortcuts, you can see the icon for workload management. See, the workload management consists, you can run on a on-premises or you can run on a cloud. Anywhere you can run the workload management. And let's try to understand the definition. Workload management enables deploying and managing Kubernetes workload in vSphere. So that means before we understand the workload management concept, we have to learn what is the importance of Kubernetes. Okay, so deploying and managing Kubernetes workloads in vSphere. By using workload management, we can leverage both Kubernetes and vSphere functionality. Okay, so not only vSphere virtual machines, we can also maintain a Kubernetes workloads. Once we configure vSphere cluster for workload management, and it become as a supervisor cluster. Normally we aware of vCenter level cluster, we can enable with a high availability DRS, and we can enable with vSAN. Multiple cluster concepts we have an idea, and we also configure data store cluster for the storage DRS feature. Similarly, if you want to configure a workload management, when we enable a workload management feature, it will become as a supervisor cluster. So try to familiarize this word, supervisor cluster. We can create namespace also like a one of the resource pool content, and namespace that provide. So resource pool means it consists of compute, networking and storage resources for running our Kubernetes applications. So we can also configure supervisor cluster with the policies for resource consumption. So for resource consumption, if you want to set any limits with the CPU level, memory level, or storage based policy management, we already aware of storage policies. Those policies also we can apply for this supervisor cluster. Okay, so that's the reason why we are going to learn container Kubernetes. This is the underlying concept included with Tanzu. And modern applications. If you want to deploy workload management, the main prerequisites for setting up a supervisor cluster, these all the key requirement. The green color one we already familiar. It require a network support. This network support should be either NSX or vSphere distributed switch. Suppose if you are using a virtual switch, this concept is not compatible. The minimum pre-requirements are only the vSphere distributed switch, or you can use a NSX. But NSXV already it's the end of support, so we have to use the latest version NSXT. Okay, NSX transformer flavor only. It's supported for a vSphere pods and Tanzu. See, there is another keyword terminology pods. Okay, and HE and DRS support we are already familiar. So if you want to configure workload management cluster, it should be our cluster should be enabled with these two features. Okay, and storage policy also we are familiar. We discussed the storage policies during the software defined storage concept, virtual SAN, virtual volumes. We discussed about SPBM, storage policy based management. The same policies are applicable for a workload management as well. And now the new concepts are I highlighted in the orange. This is the load balancer. Same like our virtual machine workloads, our virtual machines load balancing purpose, ESXi host layer load balancing, we are using DRS. Similarly, for our Kubernetes cluster, all your Kubernetes containers also required a load balancing mechanism. So for that load balancing mechanism, either we can use a open source tool. That open source load balancer tool name is called it as HA proxy. Either you can use a open source tool or you can use a NSX advanced load balancer. This is also one common requirement to configure a workload cluster. Workload management cluster, if you want to configure workload management cluster, or we call it as a supervisor cluster. So for this supervisor cluster, load balancing also one of the requirement. And once we configuring, there will be another requirement is TKG service. TKG means Tanzu Kubernetes Grid. See, Tanzu also it's underlying, it uses a Kubernetes product only. Kubernetes is an open source product, but VMware they make this as a enterprise product and they are providing a external technical support. They are providing additional technical support. That's why they put the in front of the Kubernetes, they added their original product name Tanzu Kubernetes Grid. So this is also, it is a minimum requirement. Tanzu Kubernetes Grid is nothing but we have to copy all the binaries to the one of the content library. Okay, so these are all the pre-requirement. But before we dive into this concept, we'll focus on what is the Kubernetes container and pods concepts we will discuss now. So introduction to containers. So containers meaning is the application is separated from the operating system. Earlier, if you want to install your operating system, we have to verify. If you want to install any application, we have to verify whether this application is supported for our operating system or not. For example, we have a VMware, our familiar application is VMware Workstation software. This workstation software is a host-based virtual machine software. If you want to install this VMware Workstation software is supported only for the Windows operating system. If you want to run the same workstation software .exe file on Linux platform or Macintosh OS platform, it won't support because there is a dependency. This VMware Workstation software can able to run only on a Windows layer. But the container concept is their completely application is separated from the OS. So that means there will be no OS dependency. It's like a completely separated from operating system and packaged with dependencies. Whatever the dependency files are needed to run that application, they just disassociated from the OS, they make it as a one package. If you see in the right side diagram, it is a applications. It runs with a very lightweight runtime. What is the main dynamic link library files are needed? Those files only they will collected and make it as a one package. That means this container you can run irrespective of any operating system. You can run on a on-premises, public or private cloud. You can run on a Windows platform, Linux platform, or any other OS platform. That is the importance of container. But in the physical view, in our easy understanding, this is the physical containers, how it looks like. If you see, there is a multiple colors of physical containers, but each container you can include these containers are like a one container you can include for a home household items, and another container you can include for a electric items, or another container you can use any of the other materials. That means each container we dedicated for a one specific materials. Similarly, our application also, whatever the applications you are going to use, that application our developer will help us to make this application package. That package is combined with a runtime libraries. Nowadays, mobile applications are more popular. Whatever that we have a website or anything, even in our mobile, there will be so many applications. How these modern applications are running means these all backend, they are also using a containerized applications. Okay, so now let's understand the before containerization challenges. Normally in the before containerization challenges involves like a our traditional scenario. Let's say here we have one physical server. One physical server means the server is running with a operating system, any operating system, Windows, Linux, Solaris, any other. And on top of the operating system, we can install a multiple applications. So this application involves like a project related applications like SAP, MSBI, SQL, Oracle, any of the project related application we can run on a system. Suppose your customer have a 10 different type of applications. All the 10 applications in our physical server, it's not recommend to run all applications on a same server, because the users, application users, there will be, they're trying to access same time on the same server. The traffic will be huge traffic. So just a minute. Sorry. And the scenario is for our physical server applications is suppose if you have a more applications, we need to buy a additional servers to run our project related application. So the challenges involves here is, the main challenges are within our hardware there will be some version conflict. Suppose some applications, it may require a specific hardware configuration, we cannot run for any hardware. So there will be some version conflict, not only for hardware layer, even for applications also there is some compatibilities on operating system layer. And the changes in any layer affects all. Changes in any layer is nothing but if you want to modify some CPU, or if you want to increase your hardware memory, for hardware memory increase also, we have to get the downtime from the customer. We need to power down the hardware and power down the application, shut down the operating system, and then open your server from the rack, and you can insert your new hardware components like replacing the RAM or replacing the network card. For all the any change, not only hardware, even if you want to do some modification on OS upgrade, if you're planning to upgrade your operating system from 2016 to 2019, during this upgrade scenario, we need to get the downtime from the applications team. So that means for our OS upgrade activity also there is impact for the application. So that point highlighted in the second. Changes in any layer, either hardware layer, OS layer, application layer, it affects all the environment. And hard to replicate. Even if you want to replicate your physical server from primary site to secondary site using a disaster recovery product, any of the disaster recovery tools like VMware SRM, or if you are using any of the third-party tools, Veeam or Commvault, any other Veritas Net backup tools for disaster recovery scenario also. In our traditional environment, if your hardware in the source environment, whatever the model or configuration is using, the similar type of hardware we have to maintain in the destination. If your hardware is having a different model and different type of configuration, there is some configuration issues during the replication that we can expect in a traditional environment. And also dedicated effort. Even if you want to provide any of the support, we need a separate team for application, separate team for OS management, and separate team for a hardware management. So dedicated effort is needed for each layer. That is a challenge if you are using a physical server. Not only one server, even the second scenario I just highlighted, if you have a n number of physical servers, the challenges, there will be some more additional challenges. Along with these four challenges, there is additional challenges include servers patching is tough. We have to do a servers patching for every time. So servers patching is also one of the challenge. And duplicated maintenance effect, whatever the maintenance you are performing on one hardware layer, the same maintenance we have to do for other hardware, and even the patching activity we have to perform for all the servers. So duplicate maintenance effect every time. And inconsistency and hardware compatibility issues, this is a common in a traditional environment. And even as we know, total infrastructure cost is very huge cost. Okay, so this is the before containerization, all the challenges. But not only limited to traditional, even in the virtualization scenario also, if you see the third scenario, virtualization, even in the virtualization scenario also, we are aware that First, we require one hardware. On top of the hardware, you can install a virtualization hypervisor. That hypervisor name is ESXi operating system. When you install ESXi operating system, the benefit of ESXi is, as we know, it allows you to create a multiple virtual machines. This virtual machine, each virtual machine is installed with a guest operating system. Again, on top of the guest OS, we can install a application. While installing application, the underlying is it requires some runtime on OS and requires some files to run this application. Okay, and I took the example of two virtual machines here, and virtual machine patching is still tough or hard. That means, how we did in a traditional environment server patching, the same scenario applicable for a virtual machines also, and even the maintenance effect also it's applicable for virtual infrastructure. But only the difference in the physical and virtual is balanced virtual infrastructure and compatibility issues are very minimal. Compared to traditional, there is will be a more compatibility issues, but in the virtual environment, the compatibility issues are very lesser. And the cost, we already know the total infrastructure cost when compared with the traditional and virtual environment, virtual infrastructure cost is less than the physical infra cost. Okay, so this is the scenario 3. And now we'll just involve going to discuss about how we are going to address these challenges in application perspective. So that is a after containerization solutions. After containerization, the main solutions are like a, we still need a one hardware. On top of the hardware, we can install the ESX type 1 hypervisor operating system. I took the example of ESXi. Uh, on top of the ESXi, we can create a multiple virtual machines. Because virtualization means it is a technology, it allows you to transform hardware into software. So we can create multiple virtual machines. For our easy understanding, I took the example of one virtual machine. Let's say this virtual machine is running with a guest operating system. Along with the guest operating system, we are going to configure a container host plus engine. So these two components are going to configure. The most popular container host is Docker. Okay, so for our easy understanding, I took one virtual machine, the same scenario applicable for multiple virtual machines. So within one virtual machine guest OS, I configured as a guest OS, guest container host plus engine. On top of the container host and engine, we have to configure a multiple applications. See, with earlier, if you want to run a application, multiple applications on one VM, it's not possible. For each and max, we can run one or two applications. If you want to run a more than 10 application, the scenario is we need to prepare a multiple virtual machines. But if you are using a containerization, the benefit is within our virtual machine guest operating system, we can run a multiple container applications. So containerization, we already discussed, it is like a modern applications. It's packaged with a small lightweight containers. So lightweight container, we can easily run on a within one virtual machine. When you are creating a multiple virtual machine, our main intelligence is ESXi operating system to create a multiple virtual machines. Multiple. Similarly, if you want to run a multiple applications, the main intelligence here is the intelligence of creating a multiple container is container host, which is Docker. So using the Docker only, we can configure a multiple containered applications. So the benefit of doing this container application is better hardware utilization. Same like earlier, we are creating multiple VMs for better hardware utilization, but now it is like a better utilization of virtual machines. That means it is one more layer enhanced. And reproducible builds, even in case of any one package is down also, it is always easy to reproducible. That means we can rebuild. And avoids lock-in. Lock-in means, suppose in our virtual machine scenario, every virtual machine, if you register on ESX1, that is registered and locked for a ESX1 until unless if you migrate to another host, then only it will release us the lock-in technology. But when it comes to the container application, there is no lock-in mechanism. Okay, and rapid or fast or speed deployment is possible within a container applications, and security also available, and assurance guarantee and balanced infra can be configured within a container host applications. And also the application performance also, even it is a lightweight, so there will be no issues on your application performance. It's always have a speed performance. Okay, now we'll talk about a conceptual diagram. Let's say here I took the example of one virtual machine on top of one VM, multiple applications. Suppose if you have a multiple virtual machine, let's say our ESXi host hardware with the ESXi and OS with container engines, and then you will configure so many containers, not limited to one container, multiple containers. So if you can configure a multiple container, the icon is looks like it's a big ship is running with a multiple containers. So many containers in one ship like a real ship. So even in the real ship, if you see the physical view also, one ship is managing a multiple container. The same scenario, our Docker host is maintaining a multiple containers. So this is one of the conceptual diagram for our easy understanding. Now let's try to understand the container terminology. So within our terminology, now we trying to familiarize this word container. So container means an application packaged with dependencies. Okay, and container host means our virtual machine only, a virtual machine or physical machine on which containers run. Okay, and normally container host, most of the scenarios, it's recommend to run on a virtual machine layer. Okay, compared to physical machine. And container engine is nothing but a runtime engine that manages the containers on the container host. So whatever the container host consists of multiple container, all these containers is managed by container engine. And Docker, so let's understand the Docker definition also. Docker is normally it's a company name, and Docker is the most recognized runtime engine for container support, which is often used as a synonym for many aspects of container technologies. So wherever container host is coming, most of the time we are using the technologies Docker. Now, compared to Docker and Kubernetes, the Docker also have some limited challenges. Docker or container technology have some challenges. To address those challenges, we require a concept called Kubernetes. So Kubernetes also, it was developed by Google. So Google developed orchestration for containers. Orchestration is nothing but is automating many tasks together. So for the Docker containers, advanced concept is Kubernetes. Okay. And also for our easy understanding, if you want to manage a single ESXi host, we can connect the single host using a vSphere web client or vSphere host client. Suppose if your environment have more than 2 ESXi hosts, or if you have 100 ESXi hosts, to manage single host, it's a challenge. So that is the reason VMware introduced the concept called vCenter Server. So vCenter Server main importance is it is a management tool. It allows you to manage all your ESXi hosts. Similarly, Docker host also, we are running the Docker host on a virtual machine layer. But to manage multiple Docker hosts, let's say you have 100 Docker host VMs. To manage all the Docker host VMs in the application perspective, we required a Kubernetes tool. Okay, Kubernetes is a orchestration. That means automation tool for the containers. Clear? Now we are going to talk about some more points on containerization. What is the key components in containerization? So containerization key components involve, here in the diagram, I highlighted 5 key components. So let's start from the first point. So first point is our developer will prepare a Docker file. This coding and all, we no need to worry. This will taken care by developers. But as a vSphere technical consultant, we should have some basic idea what is Docker file. So Docker file basically it consists of a AML code. So AML is nothing but a yet another markup language. So the either AML code or some different type of Go language or any of the language our developers will use, and they prepare a one code in a file. That coding file is also called it as a Docker file. Okay, and once we prepare the Docker file, this Docker file is built into the Docker image. It's like even if you want to install one operating system in our virtual machine, first we need to create a VM, and then we can mount the ISO file or CD or DVD to install the operating system. Same way, if you want to install a application also, first they will prepare one Docker file. In that Docker file, they put all the code is here. So where I need to get the file, all the information you can find in the Docker file. Docker file explanation also I will cover in the following slide, but try to understand that this Docker file is built into a Docker image. Image means it's like a our ISO file. So it consists of the actual package information. That package information is deposits into a Docker. So that this will be like a I give an example of either Docker or you can register into a Harbor, because not only Docker, we have so many third-party tools to provide a image registry functionality. But in our easy understanding, I just highlighted the most popular image registry vendors. But most of the time, the number one preference is Docker only. But some companies, they may go instead of Docker, they may go for some other third-party tools also for this image registry purpose. So once the Docker file is, it's submit the information to Docker image, that image is deposits into a image registry, which is either Docker or Harbor. This is also tool name Harbor. And this Harbor is the third step. And again, this image registry is pulls from the virtual machine. How our virtual machine install this application is, it will automatically pull from the image registry. Whatever the image registry configured on VM level, from that image registry, it will pull the specific binary file, a Docker file, and it will start creating a applications. So application creation is pretty simple. It is like a application runtime plus binary libraries only. And in this scenario, we haven't highlighted the hardware. That means this Docker file not only on a virtual machine, hardware, on premises, public, anywhere you can run. That is the importance of this modern applications, and we can also call it as containerized applications. Okay, the initial stage, whatever the developer is doing, that is comes under the development process. Once it is created and the container is ready, then we need to coming to picture. Our VMware admins or vSphere administrator coming to picture to do the operations. Okay, our knowledge is needed to manage here. Okay, and the development knowledge and all, if you are interested, you can learn the ML scripting and all. But our main scope is comes under once the container is created, how effectively we are managing all our virtual machines. Similarly, how effectively we are managing the all the containers. That is the our responsibility. Okay, and here I highlighted the same point. Docker is the most used container engine. Okay, now let's talk about a some high level overview of Docker file. So Docker file, normally it looks like a, this is the Docker file. I just highlighted here some key items. Suppose the first line, it refers as a Go language 1.9.2 as a builder. It's a defines as a which operating system or which application we are going to install, and run the make directory. Make directory means create a directory, one folder, and we are creating one folder in a GitHub. Once we create a GitHub one folder, on top of that, we are going to run our dependencies. So install the dependencies. This is the code to install the dependencies. And then we have to build that project. And then we can create a container image. That container image only we highlighted here, Docker image. Okay, and then finally this takes only the binary file. That binary file is pulled from the our image registry. It will register this information. So this is the how the sample Docker file is looks like. And the container also, it consists of application and whatever the lightweight runtime and libraries only inside the container. Okay, now we'll talk about a containers overview now. So container is an encapsulation of the application and dependent libraries and application. The application related dependent binaries and libraries. So this binaries and libraries, we call it as a dependencies also. And the application is decoupled, or we call it as disassociated from the operating system, becomes a serverless function. Even this using the containerized application, not only microservices, we can also implement a serverless functions also. Okay, that functionality also available. And among the reasons that containers were popularized by the software developers. are they make the coding easier. Our developers, they make the coding easier locally and anywhere. So you can run that code anywhere. We can deploy and test applications quickly in a staging environment. No operating system or load is required. Okay, so even sometimes if you want to run some application, there is a compatibility issues. Few applications will support only for Linux and few applications only supported for Windows. Example, if you have a .exe file, .exe means it's a executable file. This executable file normally it's supported for Windows flavor. And if you have a any of the RPM file, Red Hat package manager file, .rpm files we can able to run on a Linux environment. Okay, that is how. But in the container perspective, there will be no dependency to the operating system. You can run anywhere. Now we'll talk about the another point of containerization, that is container host. So within our architecture, we have a hardware. On top of hardware, we have a hypervisor, which is ESX, and we created a virtual machine. Within a virtual machine guest OS, you can run either Windows or Linux because the containerization now supported for a Windows flavor and Linux flavor. Any flavor we can run. Now the container host, what is importance of container host? The container host runs the operating system on which the containers are run. Container host can be following types. Standard operating system with container engine installed. Normally the most popular one is Ubuntu with Docker. Ubuntu is the operating system name, and this operating system is configured with Docker. And OS developers specifically with containers in mind. There are some specific OS also for container Docker concept, that is Photon operating system and also the Fedora core OS. Photon also used by VMware as well, and Fedora core is like a third party operating system. And virtual, you can run this container host on either virtual machine or physical machine. Among the many benefits of using VMs are easy management and scalability. So VMware also recommending that you can run your container host or Docker host always on a virtual machine level because of easy management and scalability. Okay. Now, some more points on container host. So administrator provide a container host, which are the base structure that developers use to run their containers. A robust or a healthy microservices system includes more deliverables, many of which are building to use containers. So for developers to focus on the providing services to customers, operations must provide a reliable container host infrastructure. So in vSphere, our main concept is vSphere with the Kubernetes, or we can say vSphere with the Tanzu. The container host are Photon based VMs. So Photon is like a VMware developed operating system. Okay. Now we'll talk about another point, containers at runtime. So containers runtime also one of the key point. So container runtime have a following features. A container can run on any container host with the same operating system kernel that is specified by a container. And a running container is accessed by a fully qualified domain name and its IP address. Because how we are going to access a container A, container B? You can access either by host name or you can access by IP address. Same like how we are accessing a virtual machine. And each container can access only its own resources, its shared environment. Okay, shared environment, same like in our ESX host, if you have VM1 and VM2, while accessing your virtual machine 1, our virtual machine 2 is completely isolated. Same way, even our container A and container B also completely isolated. And another benefit of containers is, suppose in our one virtual machine is running with a MS Office 2016. I want to plan to upgrade MS Office 2016 to MS Office 2019. While upgrading your application, MS Office application from 2016 to 19, definitely it will overwrite the 16, it will install a 19. We cannot run the same Office 16, 2016 and Office 2019 on a same system. We cannot run parallelly on a same. But in the containerization, even if your application with a two different versions also, we can run simultaneously on your virtual machine guest OS level if you configured with a container host. That is the importance. So that point only we highlighted as a each container can access only its own resources in shared environment. So there will be no conflicts between container A and container B. Both are a completely a own resources. When we log into a container using remote terminal such as SSH secure shell, we see no indication that other container are running on a same container host. Same like our virtual machine. Even if you log into VM2, when we log into virtual machine 2, we didn't know this VM is running on which ESXi host. Same way, even in the container also, when we log into any one container, we cannot know we are logged into container B, but we don't know about our backend container host. Okay, it's completely isolated. This is the important point. And same way, we'll dive into the one more key point is container engine. So I just highlighted container engine here in this diagram, right side diagram. This container engine, as we mentioned, it is like a control plan that is installed on each container host. When you configure a Docker host, this Docker host by default, it comes with a container engine. This container engine is acts like a control plane of all the containers. So same points I'll highlight it here. The control plane manages the containers on the host. Container engine performs the several functions. What those several functions are: build container images from a source code. Just now we talk about Docker file. So this Docker file images, if you want to move it to the containers also, the main key role is container engine. Alternatively, load container images from a repository. So you can load your container image either from a image repository, or you can pull from a Docker file, and create a running containers based on a container image. So we talk about container image, it's like a ISO file or any of the image, and commit a running container to an image and save an image and push it to a repository. So repository is nothing but any of the GitHub also, we can call it as one repository, or in a vSphere perspective, content library. Content library also considered as a repository. And this container engine have some additional functionalities like stop and remove container. We can anytime we can stop the container, we can remove container using container engine, and suspend and restart. Same like our virtual machine using ESXi host or vCenter level, we can power on VM, power off VM, reset, restart. Same way, we can also do the specific micro application, microservice application containers also. We can stop anytime, remove anytime. You can do suspend and restart power cycle operations, same like virtual machine. So report container status, even the container status also we can get the report, same like a virtual machines. Okay, now some more additional point on container engine. So container engine, see, I again highlighted the point here. Docker is the most commonly used container engine. So this is the icon for a Docker. And the container engine runs as a daemon process on container host operating system. When a user requests that container is run, the container engine get the container image from an image registry. So this image registry we can use either a Docker, or you can use a Harbor third party tool also we can use for image registry, or you can register a local also, like you can upload the image from any of the data store, or you can upload it to a content library. That is mean of local. And if you already downloaded and runs the container as process, one process will be run here. Okay, and now we'll just try to compare the what is the difference between virtual machine and container. So here the high level differences: virtual machine and containers work in a different ways. Virtual machine, as we know, encapsulation of an entire operating system. That means it's a group of files, VMX, VMDK, and VRAM file. But here container means it's a like a encapsulation of an application and dependent binaries or libraries. Okay, library means it's a dynamic link libraries, DLL files, and scheduled by hypervisor. Hypervisor means our virtual machines always scheduled by the ESXi host, but containers are scheduled by the your container host operating system, which is Docker host. And here the virtual machines run on the ESX hypervisor, and here containers run on the container host, which is Docker. And starting a VM means it's like a starting operating system, seconds to minutes, but in the application perspective, the time is very minimal, milliseconds to seconds. So starting container means starting the application process. Okay, so let's try to understand the graphical view of difference between virtual machine and containers. So the modern application, virtual machine versus container. If you are using virtual machine, an application used to build on VM. But VM offer a advantages, secure, reliable, high availability. That is in a virtual machine scenario. But when you plan to make this VM into a Docker host, there will be a additional benefits. That additional benefits involve within your virtual machine guest OS, we configured as container host. On top, we have container engine. This engine will allows you to maintain a multiple container applications. But in the previous scenario, we have one application, but in the container scenario, we can use multiple application. So the benefit is instead of using a suppose if this three application, if you want to run without containerization means we require a three virtual machines. But if you are using containerization, instead of creating a three virtual machine within one virtual machine, you can configure the Docker host and it will automatically configure a container engine. Using this engine, we can easily manage the three containers. Okay. So modern applications are built on containers and containers runs on virtual machine. And the container offers advantages portable. Portable means anytime you can move this container from on premises to private to public. Anywhere you can, it's a portable. It's easy to carry and move. And packable and easier to update. Even if you want to update any version of latest application also, it's easy to update. There will be not much challenges, same like your traditional monolithic applications. Okay. And due to these reasons, the current market is year over year, the growing of containerization is keep growing. Okay, let's slide. We talk about a rise of containers. So year over year, YOI in short form is growing every time. This is all the survey results. So survey results from 451 research. It is surveyed conducted by the 184 vendors. They did the survey, but they what is their prediction is our containerization applications is keep on increasing. They expected to by end of year 2022, the containerization market revenue may reach to 4.3 billion. So 4.3 billion US dollars. This is the prediction by 451 research. Okay. So for this research, 184 vendors are participated. So vendors means one organization, 184 organizations are participated. This is their research. Even if you see nowadays, the containerization is more popular. This survey result was given in the around 2018 time they given this result, but this prediction is absolutely accurate and our containerization is keep growing this years also. Okay. And even there is another prediction by other vendor. They are saying that in future by 2025 our containerization market may grow until US dollars 8.2 billion dollars. Okay. So that's why we are learning containers also. Even vSphere also enhanced their virtual machine innovation to, they extended their innovation to containerization. That product only vSphere with Tanzu. And containers are new format of virtualized workloads. See, until now we talk about ESX, vCenter, virtual machine, but maybe in the future, most of the companies they talk about only the modern applications, like they talk about containers, microservices only. Instead of VM, they will talk about only the your microservice application is down or not. This only we can talk. Okay, same like how we are talking about virtual machine. That much familiar will be future. We are going to use a all containerization application, or we can say microservice applications. And even same like virtual machine, even container also require a CPU, memory, network, and security and storage. These all the common resource requirements for containers also. And containers satisfy developers to need for speed by removing dependencies. The main purpose of container is there is no dependency on underlying operating system. This is the main key point here. And provide an easy user experience for developers that is infrastructure agnostic. Agnostic meaning is it's run on any cloud. And eventually, application developers are quickly adopting container technology as their tool of choice. They can go with any of the containers, either Docker, any of the other third-party tools also can go. Okay. Now, we'll try to observe the architectural differences between monolithic and microservices. So monolithic means normally in our previous architecture, we call it as monolithic architecture. Application is run on a single device. Here, application within the application, you have a order, user interface, users. That means who are the users have permission to this application, and the specific application product name. This is a monolithic architecture. And even this application within a one server, you can run max one or two application. If you want to run 10 application, definitely monolithic is not supported. So for our easy understanding, I took two applications in monolithic architecture. Even this architecture to store application data, we require a database. That is the monolithic architecture. But when comes to the microservice architecture, only difference is they break it down all the applications. So break it down means there will be no infra dependency. So there will be a separate microservices. Suppose the left side monolithic diagram, we have key components are UI. The same UI they divided into separate UIs, and to access the applications, they make it into a API call, application program interface call, and user. Instead of using a multiple dedicated application user, they make it a separate user app, and order app, product app, and even the data also distributed. So that is the reason this microservice architecture, we can also call it as distributed service applications. Okay, so distributed service means whatever the service is given by application, all the services are distributed. One, the service is the user service, that user service stored in user database, order service stored on order database, and product app stored on a product database. Okay, the same point I highlighted in the description. Containers are an ideal technology for supporting microservices because the goals of container is lightweight, easily packed, can run anywhere, and align means line up or support well with the goals of a microservices architecture. Okay, so some more key points of microservice architecture we'll talk about in the following slide. So application run on code-based environments so are designed for a failure in mind. Okay, and you can run this microservice on any of the cloud. They are built to be resilient. Resilient means strong, and to tolerate or allow network database outages and to degrade gracefully. Any scenario, it will run smoothly. And typically, cloud native applications use microservice-based architectures only. The term micro doesn't correlate to line of code. It refers to the microservice, mainly that refers to the functionality and responsibility. And each microservices should be responsible for specific parts of the system. So they make it into multiple parts. Okay, and the application is broken into multiple services, including a UI and user order product. Whatever we highlighted in the diagram, the same point. And each service has its own database. And with this architecture, each services can be scaled independently. Even if you want to increase the your user app scaled independently means you can increase the resources, CPU, memory, disk. For example, during the busy time, the order service might need to be scaled to handle the high IO or high throughput input output. Also, we can increase anytime. That is the flexibility we have in the containerization microservice applications. But still, until now, we talk about all the container application benefits, but still there are some of the key points are missing. So now let's talk about containerization challenges and what is missing. So here the missing concept is load balancing. Within our containerization, there is no load balancing. It is like if you have a one ESXi host, it's running with multiple virtual machine. When your ESXi host one is down, definitely your virtual machines are down. Same way, even if your Docker host is configured with a multiple containers, when your virtual machine virtual machine down means your Docker host also down. There will be a huge impact to your containers. So we have to protect our container applications. So that facility is not available in a Docker host. So that is one of the missing item. And even the security, we have a security only within the application layer, but what about your hardware security or virtual machine layer security? So there is some security challenges still involved in a Docker. And provisioning high availability, even there is no high availability mechanism. Same like our ESX host, if you have your organization with single host, there will be no high availability, no load balancing. Same scenario for Docker host also. And the scaling, if you want to increase CPU and memory, there will be some slight challenges. So to address all these missing challenges, there is a new concept called container. to address the containerization, we have a concept called Kubernetes. So Kubernetes, this is the introduction to Kubernetes. In short form, we call it as K8s. So K8s is nothing but a Kubernetes. So Kubernetes is a solution for container challenges. Whatever the challenges we have in container, to address all the container challenges, we require a Kubernetes. Okay, that is the importance of Kubernetes concept. Suppose for our easy understanding, I took the capture one diagram from Google. So this is a normal ship. In a ship, if you want to drive your ship, this is the steering icon, steering. The same steering icon they used for a Kubernetes. Okay, because the Docker icon is looks like a ship icon. To drive this ship, we require a Kubernetes. Okay, so this is a normal physical icon. This is a conceptual application layer icon. This is an icon also same like a ship steering icon. Okay. Now to manage the Docker or to address the Docker or container challenges, we have to learn Kubernetes. Okay. So let's talk about the Kubernetes overview now. See, Kubernetes also one of the important concept, same like our virtual center concept. So containers are managed on a single container host. See, always containers on a single host only. Managing multiple containers across multiple container hosts create many problems. So those problems are not only our previous challenges. There are some additional points I highlighted here. Managing large number of containers. If you have large number of containers, it's very difficult to log in every time to each container host. And restarting failed container, even if there is any failed container, we have to restart manually also one challenge. And the scaling containers to meet capacity. Suppose your customer is planning to do some additional data or additional modification on application layer, it requires some additional CPU or memory resource increments. That capacity planning is also very challenging if you have a multiple container hosts. And networking and load balancing. These are all the challenges in container host. So Kubernetes provide an orchestration layer. Orchestration means providing a automation for multiple tasks. So orchestration layer to solve these problems. So Kubernetes, we also call it as K8s, K number 8 and S K8s, or some we also call it as cube. So if anywhere if you read the sentence cube or Kubernetes K8s, that is nothing but a Kubernetes and is an open source container. So this is the key point. Kubernetes is also open source product. So that means if you are running in a production, if your production Kubernetes down, there will be no support. This to addressing the Kubernetes issues, our VMware Tanzu coming to picture. So VMware Tanzu is nothing but it's a enterprise Kubernetes platform. Enterprise means we are providing a support also. In case of any issues happen on your Kubernetes, we have a technical support team from VMware. That is only the importance of TKG, Tanzu Kubernetes Grid. But while providing a technical support, they have to make some name. So the open source product still the concept is same, but they are providing some additional tools. Those tools are the VMware, they make it as their own tools. The tool name called vSphere with Tanzu. Okay, but underlying core concept is still same concept, containerization and Kubernetes. So let's talk about the remaining point. Kubernetes is an open source container orchestration platform that automates many of the manual process involved in deploying, scaling, and management of containerized applications. Okay, hope you understand this point. Now we'll talk about the Kubernetes use cases. So use cases, obviously, whatever we discuss until now, the challenges, all the challenges addressing is only the Kubernetes use cases. Now let's dive into the Kubernetes objects now. So Kubernetes object is like a one of the key object involves like a pod. So pod means you can think like pod is nothing but a Docker host. That Docker host in Kubernetes terminology, we call it as pod. Pod is nothing but it's like a virtual machine only. Okay, but instead of Docker host, we call it as pod, means it's like virtual machine. To maintain multiple virtual machines, we need a Kubernetes. Same like to maintain multiple ESXi hosts, we require vCenter. But to maintain multiple pod inside the pod, you can maintain either one container or multiple containers. Okay, that flexibility we have. So pod actual technical definition is smallest deployable unit of computing that can be created and managed in Kubernetes. So the pod may contain either one container or more containers. So in this diagram, I highlighted that, excuse me, I highlighted one pod consists of two container, another pod consists of one container. Okay, so let's familiarize this word also, pod. Pod means it's a smallest deployment unit, and pod is like a virtual machine. Okay, but it is in a applications terminology. Now let's talk about some more additional Kubernetes objects. Those objects are a replica set, deployment, and service. So in the left side diagram, we'll start talking about from bottom to top. So replica set means the name itself, it says replica set. If you see in this diagram, there are three pods involved. So replica set means it maintain the number of copies of a pod, also known as replicas. So if you are maintaining a multiple copies, that copies we call it as replica set or we call it as a replica. Why we are maintaining a multiple copies is in case of one pod is down, there will be no impact to your production applications. Okay, those applications we can still run from a other pods. So that means always we should maintain some replicas. Replica means maintain a number of copies. In this diagram, I highlighted for our easy understanding, I highlighted three copies. Okay, now how we going to maintain these pods and all is to make use of these replicas to do the amazing things like scaling, rolling update. Rolling update means installing a latest patch, and if you want to pass the patch or roll back to previous patch, all the brain functionality is taken care by deployment process. Okay, so that is called deployment. So deployment, what the Kubernetes deployment uses is it's make use of replicas only. While doing the one replica will be on a production, the other replicas it will take care to do the scaling, rolling update, and also the rollback. All these functionalities it can be using deployment process. Now come to the service. So service is nothing but a make a deployment available for access internally and or externally. Suppose if you want to provide this deployment package to access to your internal team, that is nothing but a service. Either you can provide the access internally or external team also. Okay, so for a symbolic, I just put a door, either yellow or deny. Okay, the gate is like a closed gate or open gate. This is also important Kubernetes objects. And now, along with these three objects, replica set, deployment, and service, there will be some additional objects in our Kubernetes, specifically to the pod level. So in a pod level, to store the pod information, this container information, we require a config map file, secrets, that means the username and passport detail, and also it require a persistent volume. This volume is mainly to store your application data. Once it is stored to store data even after pod is destroyed, else it will gone. But persistent volume means it's a permanent storage, you can able to restore your data. And earlier we talked about a Docker file. Similarly, now let's trying to understand the Kubernetes object file. This is also similar like a Docker file, but this Docker file, I just highlighted the key items in the Docker file. One of the key file is deployment. Just now we talk about deployment, also one of the Kubernetes object, and replicas also one of the object. Here in this example, replicas are three replicas, and the image means the specific application name. There is a nginx application 1.14 version, and the kind is config map. And also we highlighted some options are yellow, the service is yellowed, and the kind is like a secret. There will be some username and password. So when you open a Kubernetes object, any of the YAML file, you will find all this Kubernetes information. Whatever the Kubernetes objects we have, deployment, replica, all these files are, all the object informations are highlighted here. Okay, but the how to write this code and all, normally it is taken care by development team. But as a vSphere technical consultant, we should have some basic idea what is objects available in a Kubernetes. Okay, now I'm just trying to explain you the high level overview of software cycle. Same like earlier, how we deployed the container. The same process is like a high level process. When you are releasing a software to your production, the software life cycle involves first developer prepare a code. That code need to be feed it to the any of the image or image registry. That is nothing but a build. It's like a our we are creating one virtual machine first, and then we make it as a one template. Using the template, we can deploy a multiple virtual machine. Once we deploy all the multiple virtual machines, we are monitoring the virtual machine status. Similarly, our applications also follow the same concept. First, the developer will prepare a code, and that code need to be feed it into the any of the Docker image or any of the image registry. From that registry, application will start deploying not in a one copy based on your replication copies. Suppose you set the replicas are 4 replica, it will deploy as a 4. How we are deploying multiple virtual machine from template. Okay, just for our easy understanding, I'm comparing with our vSphere concepts. Okay, and once your deployment is finished, finally we have to monitor. That is our regular operations job. Whenever any pod down or any application down, we have to verify the application status and pod status. Okay, same like when your virtual machine down or ESX host down, that is also our responsibility. But if your ESX host is down, there will be no impact if you enable a cluster with high availability feature. Automatically HA will migrate and restart the virtual machines on another host. Same way, Kubernetes also have a similar kind of functionalities. Kubernetes also providing the high availability and load balancing mechanisms. So this is the high level overview of typical Kubernetes ecosystem. There will be some products I highlighted. Whatever the software life cycle we have here, the same way code we highlighted one product, the code repository. It's not developed by one person. Multiple development team will prepare a code repository. Once the code repository is ready, and it will submit to the continuous integration and continuous delivery or development. This CI/CD it will prepare for a Kubernetes cluster, and this CI/CD information also pulled from a either pulled from directly code repository or it's pulled from a image repository, image registry. And but in the Kubernetes, in earlier in our Docker file, we do not have container security, but in the Kubernetes, we have additional facilities like CI/CD DevOps mechanism, image registry earlier also available, but security is one additional is involved in a Kubernetes layer. And within a Kubernetes cluster, once the deployment is finished, we have to send the logs to the logging mechanism, all the application logs, and to monitor your Kubernetes cluster, we can use some observability tools or monitoring tools. I highlighted few monitoring tools here. One is observability and any specific third-party monitoring tools or Wavefront. This is the common for Kubernetes ecosystem, but it's not limited to these tools. There will be a plenty of tools. It's completely depends on the customer's choice. Okay, and now we'll talk about a Kubernetes basic architecture components now. So basic architecture components, it's like a again, I'm just comparing with our vSphere cluster just for our easy understanding. In our vSphere cluster, if you remember, when you enable HA, we have a default, it will within our ESXi host, it will configure one master and remaining three are like a, it will act like a prime. One master is, we can also call it as primary node, and the remaining nodes are acts as a secondary nodes. But here in the Kubernetes environment, the developer is nothing but a client, and the client or anyone, they have a process of kubectl process, and we have within our Kubernetes cluster, one cluster is one main virtual machine host or Docker host is acts as a master. Okay, this master also maintain a centralized API server, and the remaining cluster Kubernetes cluster nodes are acts as a worker nodes. So in this diagram, we have one master and we have a three workers, and each worker have a one specific Kubernetes process. That process name is kubelet. Each worker have a same application processes running in the backend, kubelet process. Okay, and client side it's running process called kubectl, and master is always acts as a API centralized API server. This is the high level architectural components. Now let's talk about some more additional points here. The additional points are this master is also have a API server Kubernetes cluster service. Suppose if I want to feed it into any application to the master, normally the procedure is we have to prepare one application.aml file. So AML file is nothing but a yet another markup language. This is one of the programming language, code language. This using this AML file, they prepared a some description deployment file. Suppose in this left side diagram, if you see the deployment file app1.aml, I prepared the deployment, and this deployment have a two pods. So pod means it's like a virtual machine only. Within the one pod one, there is a two containers are running, and the replica is configured as a three replicas. And pod two container name is, I mentioned container name is container two, and the replicas are two. This container name you can use any name, just for a easy understanding. I mentioned as 0203, any number you can use, just like any number. But the pod 2 we configured as a replicas are two replicas. But during this scenario, when you feed this deployment app1.aml information, when you submit it to your master node, that means Kubernetes cluster services, when you feed this information to master, what master will do is, based on your deployment configuration file, this desired state configuration will be deployed on a worker level. So if you see in the right side diagram, if you compare with the left side configuration, our AML configuration, deployment configuration file includes pod 1 have replicas, three replicas. That means in the right side also you can see pod 1, replica 1, pod 1, replica 2, pod 1, replica 3. Okay, and the second pod also you have a two replicas. That means I mentioned as a P2, that means pod 2 replica 1, pod 2 replica 2. So we have two replicas. Based on your desired file or your deployment file, the configuration is meted in the destination. The source and destination both are equal. But this distribution process is taken care by Kubernetes cluster service master. Master will take care of all this distribution based on your application deployment. Clear? Now, in this scenario, there is no guarantee. Sometimes there is a chances of unexpectedly any worker or kubelet process may down. So for example, the same options I just highlighted again. For example, here, all of the sudden, one of the worker node is down. Worker node down means one virtual machine configured with the Docker host, that VM is down. There is a chances of virtual machine down. But in this scenario, what will happen to my existing pod 1 and pod 1 and replica 2? Because this cluster main functionality is same like our vSphere HA. How when our one of the ESX host is down, our HA, how it will work is using fault domain manager. It will monitor the every 15 seconds process. Whenever any host is unable to send the heartbeat, it decides that particular host is down. Immediately it's migrate the virtual machine to another host. Same like vSphere HA concept, even in the Kubernetes also, it's an application layer concept. This cluster, how it will verify is, it will keep compare our source deployment configuration information is matched with your destination or not. At any certain time, your source app 1 configuration, replicas 3 and replica 2. When one replica is down means the configuration doesn't meet. So during that scenario, in order to maintain your desired state management, what our cluster manage mastery will do is, our Kubernetes cluster service will immediately prepare another deployment copy on a whatever the available worker is available. Suppose in this diagram, the P1 replica 2 is completely down. This replica is newly created on another worker. This process is created by the master process. Okay, so when the another pod 1 replica 2 is created, see if you see here, we have a 3 replicas available and even pod 2 2 replicas available. That means our source deployment file, whatever the file is fed to Kubernetes cluster, that same process available on our Kubernetes worker nodes. That is nothing but a desired state management. This desired state management is always taken care by Kubernetes master server, which is a Kubernetes cluster service. Okay, so it's a concept is almost similar like our vSphere HA concept, but only thing is here the terminology is application level terminology. That is only the difference. Clear? Now we'll talk about a earlier we discussed about containerization. few container concepts we discussed. To address the containers, we have a concept of Kubernetes. Now we'll talk about what is the challenges in Kubernetes. See, in the Kubernetes also there are some challenges. So challenges of running Kubernetes in production. If you want to run in your Kubernetes in production, one instead of reading all the point, one key point is Kubernetes running in the production is not easy because it's an open source product. There will be no chance of running this product in a production environment. We are okay to run in a test and development, but not recommend to run open source product in a production environment. So to address this scenario, our VMware introduced the concept called VMware Tanzu. So for years, VMware has helped to solve this type of problems for IT. So VMware can offer it expertise and solutions in this area, that is VMware Tanzu. So VMware Tanzu is mainly nothing but a enterprise Kubernetes software. So that enterprise Kubernetes software, we call it as a TKG, Tanzu Kubernetes Grid. Okay. Now it's the time to introduce the VMware Tanzu. So this is the icon for VMware Tanzu. Okay. So VMware Tanzu also, it's a group of products involved in a VMware Tanzu. Let's talk about what is VMware Tanzu. So VMware Tanzu is like a family of products and services and used to build new cloud native applications, modernize existing apps, and operate infrastructure across any cloud. This is the key point. Tanzu is supported for a on-premises, private cloud, public cloud. Okay, and the portfolio means collection of products. So the portfolio simplifies operations and enables the developers to go to market more quickly. Even any customer, they want to deploy any applications in the production, we no need to worry. We can use a enterprise Kubernetes product, that is VMware Tanzu, and more quickly without worrying about underlying infrastructure, because this Tanzu applications no need to worry about your infrastructure. You can run anywhere. And accelerating means go faster or speed up innovation and improving customer experience. That is importance of Tanzu. But in the Tanzu, we have a three types of editions available at present. Earlier, VMware released a Tanzu Enterprise also, but somehow they revoked the Tanzu Enterprise edition. But at present, as of today, we have the Tanzu editions, are three editions available: Tanzu Basic, Tanzu Standard, and Tanzu Advanced. Same like our ESX vSphere or vCenter licenses, Standard, Advanced licenses. Same way, Tanzu also have a three editions. So Tanzu Basic is mainly for run Kubernetes in vSphere. That means this product mainly to run on a vSphere environment. And suppose if I'm using a Tanzu Standard license, this Tanzu license, standard license is run and manage Kubernetes across cloud at scale. That means for large environments, normally we prefer to use a standard license. Even still, if you want to need some more additional features like our vSphere Enterprise Plus features, that scenario will go for a Tanzu Advanced edition. This advanced edition, it will allows you to deploy custom applications. Custom means we can do a multiple third-party applications also run on Kubernetes. But in standard and basic, there is some limitations. Basic means we already stick with a VMware virtualization platform. But when it comes to advanced, we have a flexibility to use custom apps in a Kubernetes. Okay. Now let me explain some more additional point on basic, standard, and advanced. The same points I highlighted, some additional point highlighted here. The VMware Tanzu editions are grouping of the VMware Tanzu products that are designed for organization at different stages of Kubernetes adoption. So any different stage, based on your requirement of stage, you can choose the standard editions, Tanzu editions. So Tanzu is Tanzu Kubernetes Grid, in short form we call it as TKG, is included in each VMware Tanzu edition. Whatever license you use, the common VMware providing product name is Tanzu Kubernetes Grid. Like when you use your vSphere edition, we have common products ESX and vCenter. Same way, Tanzu, the main product name is Tanzu Kubernetes Grid. So VMware Tanzu basically deploy the Kubernetes using a Tanzu service and using a Tanzu service in vSphere with Tanzu or TKG. You can use default vSphere integrated Tanzu product, or you can separately download the TKG from VMware website and install. Any method you can follow. And VMware Tanzu Standard. Standard edition, the main importance is you can deploy Kubernetes across multiple clouds, private or public, using TKG. Excuse me, and manage Kubernetes using VM. In order to manage your TKG clusters also, there is a other tool is released by VMware, that is TMC. TMC means Tanzu Mission Control. Okay, and VMware Tanzu Advanced. Advanced also one of the license edition, and developers use Spring framework to reduce the application deployment time. So Spring also one of the third-party tool. Normally it's used for a Java development tool. Okay, and Tanzu build service and Tanzu application catalog are used build application maintain secure and approved catalog of container image. There are always some additional services by Tanzu, that services names are build service application catalog. So these options are not available in basic and standard. That is the difference between the VMware Tanzu editions. Now we'll talk about the high level VMware Tanzu portfolio. Portfolio means collection of products. So in the collection of products, we can divide it into three categories. Build. Build means where we can build the Tanzu and where we can run the Tanzu application and how we can manage the Tanzu. Okay, that's why it's short form build, run, manage. The goal of VMware Tanzu portfolio is to provide a modern application platform. Okay, this is the key point here. Why we are using Tanzu is mainly to provide a modern application platform. What is a modern application platform? It is completely a microservices architecture. And edge. In this screenshot, I highlighted a point is edge. Edge means edge refers to an environment located in a remote locations outside of a typical data center environment. Where we can run the Tanzu is you can run Tanzu either using a external product from VMware website, TKG, Tanzu Kubernetes Grid, and Tanzu Kubernetes Grid Integrated Edition. This integrated edition is one of the old product. The latest product is TKG, but some companies they are still using integrated edition. For them only still the product is available, and the latest one is TKG only. This TKG or TKG IE, you can, if you are going for a very new to Tanzu, most preferable product is TKG only. This TKG you can run on vSphere level, then we call it as a vSphere with Tanzu, or you can run separately either integrated Tanzu or you can install separately this TKG on vSphere. Two options are available, and the same TKG you can run on a public cloud also. Public cloud means it is AWS, Azure, Google Cloud, Oracle Cloud, any of the other clouds. Even VMware Cloud also you can run. VMware Cloud means VCF, VMware Cloud Foundation also you can run, because VCF is a hybrid cloud product. And after we run this one, we, in order to manage this one, there is a some management tools, Tanzu observability, Tanzu machine control. These all the features I just highlighted the importance of each product. These concepts I'm giving a high level information today. The in detail concept we'll discuss in the later classes. Okay, so I just trying to give you what is importance of each sentence. So like Tanzu build service, what is the use of this build service? High level importance I'm giving in the next slide. So VMware Tanzu portfolio, whatever we highlighted in build, run, and manage, this is the components I'm giving here. Spring. Spring means popular Java development ecosystem of tools. See, popular Java ecosystem of tools means this is the one, Spring. So this is mainly for application development our developers will use, and Tanzu application service. This application service short form TAS. TAS importance is code development automation on VMs. So our developers will mostly work on this TAS, TBS, and TAC. TBS means build service. Build service means build validated container images. So whatever images you have, all the validation purpose will use this service. And Tanzu application catalog. Application catalog mainly for a curated marketplace of building blocks. This marketplace earlier, the one of the most common companies, Bitnami. Recently, VMware acquired this Bitnami company. Now it become as a VMware marketplace website. Suppose let's log into our lab system. If you type in the VMware marketplace, you will find this is as a Bitnami is powered by the marketplace site now. Yeah, VMware marketplace. Previously it's a Bitnami, now it's a become as a VMware official. Yeah. marketplace today. From the marketplace, if you want to download any of the either paid services or appliances or free appliances, all you can download from a VMware marketplace site. All the areas it's available. So many categories are available here. Okay, let's minimize and run run layer. Suppose in our previous screenshot, if you see the run layer, we have multiple items. This one, the main TKG, I just trying to explain here. TKG means Tanzu Kubernetes Grid and deploy and lifecycle Kubernetes clusters. The importance of TKG is to install and maintain all your update and upgrades of Kubernetes clusters. And TKGI is a previous formal product. That is, previously TKG is like a pivotal company, pivotal container service. This pivotal company was acquired by VMware. They rebranded to TKG. Okay, that rebranded product name is TKGI. I means integrated edition. Okay, but still some companies they are using the previous product. But nowadays most of the companies they started using TKG, Tanzu Kubernetes Grid. This is the latest version. Okay, and to manage all your multiple TKG clusters or Kubernetes clusters, we require a Tanzu mission control. This mission control is like a manage multiple Kubernetes cluster. But here Kubernetes cluster means not open source, it's enterprise Kubernetes cluster, and policy and config the across clouds. And TO means Tanzu observability. Observability have a additional facilities like app and cloud metrics. If you want to do any metrics tracing and analytics, these and all you can use TO. And we also have some other tools also, which is Wavefront. Okay, these all the tools I'm just highlighted, which is related to the VMware product. But in the real-time scenario, it's a completely a customer or developer's choice. Suppose in the Google, if you type CNCF, there is a open source developers community. It is called it as CNCF, means Cloud Native Computing Foundation. If you type in the Google CNCF landscape, you can find all your DevOps application development company information. If you just type Google CNCF landscape, you can click on the first link. You will find the CNCF, Cloud Native Cloud Foundation, interactive landscape. There will be so many companies is working in each layer. These all the development companies. Okay. Okay. Normally, this is mainly for if you want to save this file also, you can save it in the PDF. Okay. Here you can see all VMware other third-party company information. These companies are more focusing on the cloud native storage, some companies, container runtime, some companies, and network layer, some companies. But these all are some most of the companies are like a open source only. Even if you see scheduling and orchestration, the orchestration, if I click here, there is a Kubernetes. So this topic only we discussed today. Okay, and also there is a some other companies like Docker also available here, and even some additional companies, even our Hewlett Packard and HP also is available. That is also one of the Kubernetes certified service provider. Even under here you can find the multiple infrastructure vendors also here. Okay, even VMware also you can find here. So when you get spare time, you can just explore all this information. Okay, but within this, I'm just highlighting the more related to the VMware Tanzu only. But in the real-time scenario, it's subjected to be customer's choice. They may use any of the other tool. But as a vSphere technical consultant, we should have some basic idea on all these concepts. Okay, let's minimize this one. And so this is the one I highlighted. What is the build level tools, run level tools, and management level tools. Now let's talk about the VMware TKG. Some additional what is the solutions we can recommend. So which solution is right for our customer? We have a vSphere Tanzu or TKG. There is a some limitations. So based on your customer's choice, we can choose. I just highlighting some key features here. So comparing the enterprise Kubernetes. So enterprise Kubernetes, we call it as a Tanzu. So enterprise means we are providing a product support. But if you are using a normal Kubernetes open source product, there will be no support. In case of any issues, no one will provide you a support. But if you buy a VMware Tanzu, we are giving a official enterprise Kubernetes product, which is CNCF certified product. Okay, and Tanzu on, you can run Tanzu on a vSphere level or you can run on a VCF level. VCF means it's a VMware hybrid cloud product, VMware Cloud Foundation. Suppose the scale requirements are highly variable. Always it's a scaling is like a how many Kubernetes clusters are needed and all. This always determined based on your technical assessment. Normally this assessment is taken care by solution architects. Solution architects will do all your technical assessments, and which is the relevant product they will suggest us. But for easy understanding, I just given a some comparison between vSphere with the Tanzu and VCF with the Tanzu. If you are using a vSphere with the Tanzu, it supported maximum Kubernetes clusters up to 25 clusters. That is the scale. Okay, and suppose the VCF with Tanzu, if you are using cloud foundation with the Tanzu product, Tanzu means TKG, Tanzu Kubernetes Grid, over 20 Kubernetes clusters, you will go for a VCF. Okay, so below 25, you go with vSphere product. Over 20 means you will go with a cloud concept, VCF with Tanzu. And the deployment experience in vSphere is very fast. Within 1 hour, we can finish it, and even VCF also have a highly automated option is available. So both are very fast deployment. And the networking perspective, in vSphere, you can use vSphere distributed switch. If you have virtual switch, it's not recommended to use Tanzu. The minimum requirement, even in today our introduction slide, for Tanzu prerequisites is we require minimally distributed switch. Okay, or BYO. BYO means bring your own network device. That option also available. Suppose if you are using VCF with Tanzu, VMware Cloud Foundation, the minimum requirement is we should go with a NSX virtual networking. NSXT is needed. And for the load balancing purpose, vSphere with Tanzu have a flexibility to use BYO. BYO means bring your own load balancer device, or and one of the open source load balancer device name is HA proxy. Okay, this is a normal software appliances you can download from internet and you can use it for a load balancing. And for the VCF scenario, we should go with NSXT only. And storage also, you can use your customized any of the storage vendor, Hitachi, HP storage, Nimble, or anything you can use, or any of your bring your own existing storage also. Or one example we given from VMware storage is software defined storage, which is virtual SAN. And even VCF also recommended to use virtual SAN. Okay, this is a high level comparison between vSphere when you are using vSphere with Tanzu, when you are using VMware Cloud Foundation with Tanzu. Okay, some more additional points I've just highlighted in the following slide. And which solution is right for your customer, same point, and choose the right VMware solution to run our customer Kubernetes workloads. So the scale point, the main key point here is small to medium scale range. You'll go with this product. And this product, another key point is the fastest way to get started with Kubernetes workloads. And this is like a best way to run the Kubernetes workload at scale. And projects from medium to large scale. So medium to large scale deployment, you'll go with this tool, VMware Cloud Foundation. And small to medium, you go with this one. This is the recommendation given from the VMware. Okay, and the deployment normally it's very fast, and in the VCF we have a facility to do automation and networking. Whatever we points discussed in the comparison, I just elaborated the same points here. Okay, and load balancing level and storage level. Okay, clear. Now let's talk about the vSphere with the Tanzu, the challenges, whatever we discussed until now. The main key points again I just summarized here. The main challenges is addressed in a vSphere 7 with Tanzu. Uh, whatever we challenges we have in container and Kubernetes, those challenges addressed in a Tanzu. Okay, so the benefits of vSphere with the Tanzu is developer ready infrastructure, and it is a fast deployment, and it is providing a networking and load balancing. Okay, but all are in a enterprise grade. That means in case of any issues, our VMware team will provide a support. Now, Tanzu Kubernetes grade key capabilities. Our main key capabilities here is the deployment is consistent, always have a permanent, and also automate multi-cluster options. We can able to perform the automation within our TKG, and access integrated services align with open source. Even if you have any existing open source tool like HA proxy or anything, or your existing anything, you can integrate with TKG. That flexibility is providing by VMware. That free tools you can verify from a CNCF landscape website. Okay, so some more additional points which specifically to the vSphere 7 with the Tanzu. So Kubernetes as a feature of our existing infrastructure. And organization can run containers and VM side by side, uniform platform. Earlier, we are running only virtual machine, but now the latest technologies, VMs, along with we can side by side, we can run a containers also. Container means it's a Docker host. And operator means our system operators or IT admins can provision Kubernetes clusters similar to how they provision virtual machines. So as we know how to provision virtual machine, how to deploy VMs from template, but we should also learn how to deploy a Kubernetes cluster. But the developmenting the YAML file and all is taken care by developers' responsibility. Our responsibility is to deploy only. Okay. So developers can access resource in self-service fashion using Kubernetes APIs, application program interface calls. Okay. This is a high-level vSphere architecture. So normally the physical infrastructure still needed compute, network, and storage, and our IT admin will log into the vCenter, can manage all our TKG infrastructure. So virtual machine side by side, we are running a enterprise Kubernetes. Okay, and the main service within the enterprise Kubernetes is Tanzu Kubernetes Grid TKG service, and network and storage also needed for Tanzu. Network service means we need to use either virtual distributed switch or you can use a NSXT. And storage service, you can use any external storage or you can use a virtual SAN. Okay. And some more additional points for the same architecture is modernize 70 million plus our workloads are already running in a vSphere. So in future, you may expect all the virtual machine become as a containerized applications. Okay. And the purpose is I highlighted the 3 points here: deliver a developer ready infrastructure, and also support for a align and lineup support for a DevOps and IT teams, and simplify cloud operations. It's a very fast deployment compared to individual monolithic application, all preferring to use a lightweight microservice applications only. Okay. So the most common containerization and modern application common questions, I just highlighted the common questions here. What are the best practices running a container and Kubernetes in production? Gartner is one of the IT infrastructure layer survey organization. This always technology surveys conducted by the Gartner and Forresters, this most popular organization. Based on the Gartner predicts that by 2025, more than 80% of global organization will be running a containerized applications in production. So which is significant increase from fewer than 35% in 2019. So let's as a vSphere technical consultant, our knowledge is not limited to vSphere virtual machine. We have to enhance our skill set to containerization also, because our survey technology service survey vendors clearly saying that in future will be on a containerization Kubernetes only. So this skill is really needed for us also. Okay, and where are these containers running? This is a Forrester, also another technology survey vendor. This is also popular, and says that 87.5% organization will be building and deploying containers both on premises and in multiple public clouds. Either you can use private cloud or public cloud also. This containerization usage will be keep growing. And why are enterprises moving so rapidly to adopt containers and cloud native platforms, cloud native patterns? The main thing is the faster deployment, and also revenue will be high, revenue growth also increasing, and any issues troubleshooting also resolving very quickly, because it's a lightweight operating system. Even you can destroy the pod or you can destroy the container, you can rebuild it very quickly. Okay, troubleshooting also become very easy. And it's how they hyper focus customer experience. And also given majority of applications will be containerized and running in production on multi-cloud infrastructure in just a few years, our customers must be ready to operationalize containers and Kubernetes starting now. So it's already continuation. Okay. Now, before going to do the lab, I'm just giving a high level overview of what is the configuration needed for TKG management cluster default plans. If you want to deploy a TKG cluster in our development and production scenario, normally for development scenario, the configuration involves one Kubernetes control plane node and one worker node. Earlier, we discussed about Kubernetes cluster high level overview, right? In that cluster, same way here, enterprise cluster, one Kubernetes control plane node, one worker node is the minimum requirement for development scenario. But in the production scenario, minimally 3 Kubernetes control plane and 1 worker node is enough. And load balancer minimally 1, and for the Kubernetes API server request. Okay, and stacked etcd, this is also, it is on a, it will run this process on a single master node, and here on a 3 masters. And the configuration for this clusters is same like our vCenter t-shirt sizing. You can use small, medium, large, X large. So obviously for small CPUs are minimum and large CPUs are high, and disk size also will increase. This is the default configuration when you're deploying in development and also the production. The configurations are both almost same, no difference. But only thing is, in development we may use the small size or medium size, but in the production environment we may go for large or X large. Okay, it depends on the customer's choice. But this is a management cluster. But in order to run your production applications, we need to deploy a workload cluster also. This workload cluster is run with a actual project related applications. So this configuration also same like management cluster, and even the Kubernetes also 1 control plane, 1 worker node, and here also 3 control plane, 3 worker node. Because it's a workload cluster, worker node 1 is not enough. We need to maintain a 3 worker nodes. Okay, and load balancer 1, and even etcd should be configured on a 3 masters. This is the high level. What is the requirements to configure a Kubernetes clusters? The mainly 2 types of Kubernetes cluster. One is management cluster to maintain all your infra VMs. That means Kubernetes, Docker host VM, and main master VMs, and all run in a management cluster. And actual project related microservice applications are running in a workload cluster. Okay, and I also capture one of the vSphere with the Tanzu Objects high-level overview, and this is the lab we are going to perform. But here, if you see the high-level overview within our data center cluster, we have ESXi host. The first one refers as a namespace. The namespace is like it's a logical container, depends on your application name. If you have SAP, you can mention as a SAP one namespace, and Oracle one namespace, like that we can. Okay, that is a one logical container. And vSphere pod is like a virtual machine only. If you see the second one, it is all the virtual machine only. These all considered as a vSphere pods. And Tanzu Kubernetes cluster. Cluster means, see, this is the Tanzu Kubernetes cluster. If you see, this is all a dev cluster, dev TKG cluster. And the name also it's showing in this namespace, under namespace resource pool name is dev TKG cluster. And Harbor registry, we talk about for image registry, we can use either Docker or Harbor. So Harbor is one of the registry. See, the fourth point is highlighted for you, all are Harbor registry. And the fifth point is a control plane VMs. There will be a supervisor cluster. As I mentioned in the first slide, workload management is nothing but the cluster VMs is created with a supervised control plane cluster. That cluster is nothing but a control plane VMs are supervised cluster VMs only. In short form, we call it as control plane VMs. Okay. Now let's log into our vCenter server. I'm not going to do the lab now, just for our with interest of our time. I just show you the option. In our next session, we'll plan to deploy the tangent. Okay. Now let's log into our vCenter server quickly. You will see that option, workload management. So hope you understand the importance of container, pod, and Kubernetes. If you have any questions, let me know. So when you log into the vCenter server, if you want to open a workload management, see, this is the option. You can just click on menu, you can see workload management. Okay. In our previous session, we talked about hybrid cloud services, development center, cloud migration program. But today concept is workload management. The workload management, when you log in, just click on back. See, this is the icon looks like workload management. So workload manage the same point we discussed today first slide. Okay, so it's a deploying a managing Kubernetes workloads in vSphere. Okay, and the prerequisites, this is the prerequisites for setting up a supervisor cluster. So HE and DRS, we already have storage policy we can use, but we have a DV switch and NSX, and load balancer is not yet ready. I will prepare a one HA proxy VM, and then we can configure all this in our home lab. Okay, and when you click on get started, it will ask you to configure all this information. Even if you see the warning message, there are two warnings. First warning is no NSX instance has been installed. So if no NSX means we have to configure a distributed switch. That is the first warning. And the second warning is you must configure load balancer instance with your vSphere environment before set up a vSphere cluster as supervisor cluster. Okay, so that is the first step. Normally, while configuring itself, we can use vCenter Server. See, NSX is by default, it's detected as a not available. Okay, so next lab, I will show you either any one of the option within NSX or DV switch option. I will show you. See, DV switch also supported for Tanzu Kubernetes cluster. Okay, and when you click on next, normally it will go the next step. Currently, we are unable to go to the next. Let me try to click next. It's not going. You must create content library, support Tanzu Kubernetes grid. Okay, Kubernetes content library also needed. So then only we can proceed to the next. But just to try to understand that workload management configuration is when we meet our prerequisites, it's easy to provision a Kubernetes cluster. See, cluster we can provision storage, load balancer, management network, workload network, Kubernetes grid service, review and confirm. Once you fill all these details and click submit, it will prepare a Kubernetes cluster automatically. Okay, and to view the prerequisites, you just click on based on the once you meet all these requirements only we can provision. Okay, so you can provision using DV switch or you can provision using NSXT. Okay, for NSXT, only these three are the minimum requirements. Okay, we can test with both options. Using DV switch option, we can test and we can test with the NSX also. Okay, so that's it for today. If you have any questions, let me know. So just for a high level overview, if you see the first slide, container is the basic concept. Container, pod and Kubernetes is the foundational concepts to understand the Tanzu. So container challenges is addressed in Kubernetes. Kubernetes challenges are addressed in Tanzu. Okay, so that is easy to understand. So that's it for today. If you have any questions, let me
Yeah. If the VM goes down or any hung state, do
know.
we
Okay.
have any dependency on containers and their applications?
Yeah, definitely. That is the reason what we discussed in our Kubernetes cluster concept. When our any of the virtual machine Docker host is down, immediately, same like our vSphere HA, how it is migrating the VMs to another host, our
Container.
yeah, that the Docker host application also immediately it will migrate it to the another Docker host. That migration and initiate scheduling process, the application scheduling process to the new Docker host is taken care by our Kubernetes cluster. Yeah, here
And
we, yeah.
uh, the OS binders are there, no? It will be
Oh,
taken one only when applications are running in the
yeah, yeah, correct.
VM.
It's
Then only it is called as voiceless one, right?
yeah, correct.
And one more,
Mhm.
do we have any difference between Windows vCenter and VCSA?
Windows vCenter, the name itself, it says like a that vCenter is like a Windows supported software only. We can run on a Windows operating system. But VCSA is like a vCenter server appliance. It's like a predefined virtual machine, predefined by VMware. So there, it's no need any operating system. Already VMware developed with a one package. That package is combined with Photon OS along with vCenter server application. So we no need this appliance is like a re-architected from Windows to appliance level. In our previous 6 series only we have Windows flavored vCenter, but from 7 series onwards there is no Windows flavored vCenter. VMware completely removed the Windows flavor. We have only the appliance flavored vCenters only available from 7 series onwards.
Okay. Can we assume the pods are like VMs and
Yeah, parts are like VMs, correct.
Dockers are like host?
Dockers are like, Docker is like a we have multiple objects. Docker host means It's a main intelligence of preparing a containers, multiple containers.
Okay. If we compare with this ESXi host and all, it will be easy to understand.
Yeah, easy to understand. Yeah, Docker host means our ESX host. vCenter is like our to maintain Kubernetes. That is easy to understand.
Yeah. Thank you.
Any other questions? Okay, if no questions, we can end the session here. Thanks for your time.
Thank you.
Thank you.
Yeah, thank you. Thank you, everyone. Bye for now.